Hello students, in this video we are going to look into motion in two dimensions. The topics that we are going to cover under this topic are oblique projectile, equation of trajectory, horizontal projectile, projectile from a height, and relative motion. So the first video under this lesson is about oblique projectile. So what is a projectile motion? Any motion influenced by a single force is known as projectile motion. Now the single force can be gravitational force, electric force, magnetic force, any force. But only condition is what? It should be influenced by a single force. So projectile under gravity, yes, that's what we're going to look at, because when we consider various situations in this chapter where we're only studying about an object which is we are only experiencing gravitational force. So that is why in this case we'll be talking about object being thrown from a height or thrown from a hand or something. So till the object is inside in the hand, it's not projectile because it is having our force that is also acting on it apart from gravity. The moment it leaves our hand, only gravitational force acts on it, and from there we can consider this to be a projectile motion. Now under this projectile motion, what is oblique projectile? A body projected at any angle other than 90 degrees or 0 degrees to horizontal is known as oblique projectile. So if it is projected at 0 degrees, we call it as horizontal projectile, and if it is projected at 90 degrees, we call it as vertical projectile. So everything other than vertical and horizontal projectile we are going to look into in this particular video. So let's try to find out various parameters that are associated with oblique projectile. First we'll try to find out time of flight. So what is time of flight? The total time taken by the projectile to come back to ground. If it is thrown from a ground, that's called time of flight. So let's see, we have vertical component of velocity v sine theta as shown in the graph, horizontal component of velocity v naught cos theta if v naught is the velocity with which it is projected at an angle theta with the horizontal. So let's try to separate vertical and horizontal parts. So vertical part, I can say along vertical path, if y is the displacement, I can write y equal to uyt. Uyt is initial velocity in vertical direction plus half ayt square. So because I want time of flight, I need to find the change in vertical position from initial position to final position. This is initial position and this is final position. So you can see that both the positions are at same height. So net change in vertical position is how much? 0. So here also I'll write it as change in vertical position. And what is uy? You can see that uy is v naught sine theta. And we all know what is ay. Ay is minus g. So let's substitute it. We'll get 0 equal to, of course, instead of v, we'll write v naught sine theta into t minus half gt square. So solving this, I'll take half gt square to other side and I'll be left with v naught sine theta into t here. I'll get rid of t, I'll be left with the remaining t equal to 2 v naught sine theta by g. So the total time of flight, that is time taken for the whole journey when initial and final points are at same height, is 2 v naught sine theta by g. Now this can be classified into two parts. Time to go up, we call it as time of ascent, is half of this, that is equal to v naught sine theta by g. Similarly, time of descent, I'll say time taken to come down from the highest point. This is also half of it, so that is v naught sine theta by g. So the total time taken is how much? It is 2 v naught sine theta by g. And if I want to segregate into time taken for upward motion and downward motion, I can say it is v naught sine theta by g each. Now let's look at the next part, that is maximum height. How do we calculate maximum height of a projectile? So maximum height is due to vertical motion and vertical velocity at the highest point. At the highest point, I'll see that we have only horizontal velocity. We don't have vertical velocity. So I can say vertical velocity at highest point is how much? 0. I'll use the expression vy square minus uy square equal to 2ay into s. So vy, we know it is 0. Uy, it is how much? V naught sine theta. Ay, as we know, it is minus g. And s, that is displacement, is h. Let's substitute everything. So that will give me Vy square 0 minus V naught square sine square theta equal to 2 into minus g into h. So from this I'll get h equal to V naught square sine square theta by 2g. So the maximum height attained by a projectile motion is V naught square sine square theta by 2g. Again, this expression we have seen that is only affected by vertical velocity because vertical motion is only affected by vertical velocity of the projectile. The next thing that we are going to look at is range of a projectile. Range is the maximum horizontal displacement of the projectile, and the maximum horizontal displacement only depends on horizontal velocity, but this horizontal velocity would carry the body in horizontal direction till the object is in air. So I can say range r is equal to horizontal velocity into time of flight. So we know horizontal velocity is v naught cos theta and time of flight is 2v naught sin theta by g. So this can be written as v naught square 2 sin theta cos theta by g, right? So that can further be written as v naught square sin 2 theta by g. So range is given by v naught square sine 2 theta by g. This is the range of projectile. From this we can see that range is maximum. So range would be maximum if 2 theta is 90 degrees or theta equal to 45 degrees. So the range for a given velocity for a projectile would be maximum when it is projected at 45 degrees. The other thing that we can see is we have sine theta and cos theta. So and we know that sine 90 minus theta is cos theta. So for a given velocity, range would be same for an angle of projection theta or angle of projection 90 minus theta. So if the initial velocity is same, the range would be same if it is projected at, let's say, 30 degrees or 60 degrees. Now these conditions that we have derived are strictly the expressions that we have derived for range, maximum height or time of flight. These are strictly valid only when the initial point and final point are at same altitude. So otherwise we cannot hold them. Now change in velocity and momentum in a projectile. So in the same situation where the initial and final point are at same height, we'll try to find out what is change in velocity and what is change in momentum. Now what is change in velocity in horizontal direction? Horizontal velocity is constant, so change in velocity in horizontal direction is 0. Now coming to vertical position, when it reaches here, it will have same velocity v naught sine theta in downward direction. So what is change in velocity in vertical direction? It is v naught sine theta minus of minus v naught sine theta. I am taking downwards as positive here. So that will give me 2 v naught sine theta. So change in momentum is how much? Sorry, change in velocity is 2 v naught sine theta, and because of that, net change in momentum would be equal to how much? 2 mv naught sine theta. So if initial and final vertical position of a projectile are same, then the change in momentum would be given by 2 mv naught sine theta, because there is change only in vertical velocity. There is no change in horizontal velocity. Now let's try to get an expression for position and velocity at any time t. We have seen what is total time of flight, we have seen what is maximum height, and we have seen what is the total horizontal displacement. Let's try to get expressions for any time t. Let's say at a time t it is at this position, something like this. So this is y. Now can I write y equal to vertical velocity is v naught sine theta into t minus half gt square. So this is what this is vertical position. So and similarly, what is horizontal position? Horizontal position is v naught cos theta into t. So if I want to find net displacement, I can say net displacement equal to under root of x plus y square. Similarly, if I want to find velocity, vertical velocity is how much? Vertical velocity is we can see vertical velocity is vy is v naught sine theta minus gt. And what is Vx? Vx is V naught cos theta, because horizontal velocity remains constant. So if I want to find the magnitude of net velocity, it will be Vy square plus Vx square. In this way, we find out what is the magnitude of velocity or the displacement at any time t after projection. So after that, when we talk about position and velocity, the next thing that we have to see is what is the angle that the projectile makes at any time t. Let's say at this point it makes an angle alpha. Now this is Vy and we know this is Vx. Vy can be upwards or downwards depending on which time we are considering. So I can write tan alpha equal to how much? Vy by Vx. Now we have just seen that Vy equal to how much? Vy is V0 sine theta minus Gt. And we know Vx is how much? Vx is V0 cos theta. So from this what I can write? I can write tan alpha equal to V0 sine theta minus Gt by V0 cos theta. So in this way I can even find the angle that the object would make after time t of projection. So this is what is there in uh, the projectile motion first part, that is oblique projectile. Hope you could follow this. Thank you very much.